Let's have a look at the graphs of sine and cosine of theta. The red line is the graph of cosine of theta and black line is the graph of sine of theta between angle 0 and 90 degrees. The maximum value sine or cosine can get is 1 and minimum is 0. Their behavior is opposite. When cosine of theta has a maximum value of 1 at 0 degrees, sine of theta has the value 0 at 0 degrees. Similarly, when sine of theta has maximum value of 1 at 90 degrees, cosine of theta has value 0 at 90 degrees. I remind you once again that sine of theta is related to vertical and cosine of theta is related to horizontal component of the quantity. We can now try to find the answers of the questions I posed at the beginning of the lecture. The first question was, if force makes an angle of 45 degrees with the horizontal line, the block will cover equal distances horizontally and vertically. Why? Let's have a look at the graphs of sine and cosine of theta. We see that at the angle 45 degrees, sine and cosine of theta have equal values. If sine of theta and cosine of theta have equal values, it means they will split the force F into two equal horizontal and vertical components. If the force has equal horizontal and vertical components, the block will eventually travel equal distances horizontally and vertically. My second question was that if angle of the force with the horizontal is less than 45 degrees, the block will go faster horizontally and slower vertically. Why? To answer this question, let's have a look at the graphs of sine and cosine of theta in the area where the angle is less than 45 degrees. And this area is towards the left side of this vertical line. We see that in this area, cosine of theta is increasing with a decrease in the angles. But on the other hand, sine of theta is decreasing with decrease in the angles. We already know that sine of theta is related to vertical and cosine of theta is related to the horizontal component. It means that in the area below 45 degrees, the horizontal component will keep on increasing, but on the other hand, the vertical component will decrease. It means the block will go faster horizontally and slower vertically. My third question was that if angle of the force is greater than 45 degrees with the horizontal line, the block travels less horizontally and more vertically. Why? Once again, let's have a look at the graphs of sine and cosine of theta. The area which is greater than 45 degrees is this. Check the behavior of sine and cosine of theta. I leave the answer to you. Think, observe, and try to answer this question. I hope you can do it. A projectile motion is a motion in two dimensions. Here I have an exaggerated picture of planet Earth. Suppose we have a ball here. Now if I give a horizontal velocity to this ball, the ball will only move horizontally along the surface. If I give a purely vertical velocity to this ball, the ball will only move up and then eventually it will come down because of the gravity. Now let's suppose I give this ball a diagonal velocity along this direction. Let's see what happens. The ball follows the path like this. This motion is composed of two individual motions which are independent of each other. The ball covers a horizontal distance along the surface and it also goes up. It attains a maximum height and then it comes down. The up and down motion is governed by the gravity. Let's analyze projectile motion in more detail. Here I have my I and j unit vectors for reference. I have an object at the origin. Suppose the object has an initial velocity v making angle theta with the horizontal line. Under the effect of this velocity, the object will undergo a projectile motion like this. Since v is a vector quantity and it is neither horizontal nor vertical, it has two components. One is horizontal and other is vertical. Horizontal component is only responsible for the horizontal motion of the object. Similarly, vertical component only contributes in the vertical motion of the object. These two motions are completely independent of each other. A projectile motion happens when horizontal and vertical components of the velocity work together on the object. Let's decompose projectile motion to understand it better, and it will also help us to derive the mathematical expressions as well. At the top of the screen, we have an object with an initial velocity v which has two components. In the lower left corner, we have the vertical component of the velocity in action. Similarly, the horizontal component of the velocity is acting in the lower right corner of the screen. Remember, the horizontal component of the velocity is working horizontally towards the right side. Similarly, the vertical component is directed upward. Let's see their motions. Three essential parameters are to be considered. The first one is the maximum height attained by the object. We can call it h. The range r is another vital quantity to consider. The range is just a fancy word to show the maximum horizontal distance covered by the projectile. The time of flight t is another crucial parameter, which is the time it takes for the object to hit the destination. An important point to remember is that when calculating the maximum height of the projectile, only take the vertical component of the velocity, because the horizontal velocity has nothing to do with the vertical motion. Similarly, when you are deriving the range of the projectile, only take the horizontal component of the velocity, because the vertical component of the velocity has no role in the horizontal displacement of the object. Like I said before, two motions are independent of each other. The time of flight can be computed conveniently using only the vertical component of the velocity. The time of flight is the time for the object to attain the maximum height plus the time it takes for the object from the maximum height to hit the surface. And of course, these two times are equal.